students, I hope all of you are doing good. Let's start today's chapter, angles. Introduction. In real life, we observe that whenever two lines meet, an angle is formed. The edge of walls of the classroom, edges of doors, edges of a blackboard, etc. form angles. The two hands of a clock and the two blades of a pair of scissors and the two hands of a divider, all these give us an idea of an angle. For example, this is also an angle, this is also an angle, okay, this is also an angle, right? So what is an angle? An angle is a figure formed by two rays with the same initial point, okay? One ray, two ray, and both of them have same initial point, okay? So displacement made by an initial ray with a fixed point, the rotation of a ray from one position to the other position about a fixed point. The common initial point O is called the vertex of the angle, okay? This is the vertex, okay? And the rays OA, OB forming the angle are called its arms. These are arms. OA is, this is arm, OB, this is arm, okay? And this is the displacement, right? The arms are often joined by a small circular arc for making angle as shown in the figure above. So we name the angles as, you can write angle AOB or angle BOA, okay? And this is the symbol for angle. Also, we can simply call it as angle O, right? Now, interior and exterior of an angle. Consider an angle AOB. Then, set of points that lie inside the angles from the interior of the angle. Example, point P. As you can see here, point P. This is inside the angle. That is, this is interior point of the angle, okay? Any point or any one of the arms of the angle is said to lie on the angle. Example, point Q. The set of points which lie outside the angle from the exterior of the angles. For example, points R and S in the figure. As you can see here, points R and S. These are the points which are the exterior points of the angle. The two rays and vertex together are called the parts of an angle, right? Exercise 16.1. Name the vertex and arm of the following angles. Okay, so it is like this. AOB. We have to name the vertex. Vertex is what? O. And arms OA. Okay, and OB. Right? Magnitude of an angle and its measurement. Consider an angle AOB is the figures given below. Okay, we can change the inclination on opening between arms OA and OB by changing the amount of rotation from OA and OB. Okay, see, we have changed the rotation. Okay, first this angle was smaller, then became bigger, then bigger, because we have changed the inclination, or you can say we have changed the opening between two arms, that is O and B, OA and OB. So the inclination or opening between two arms, that is amount of rotation from one arm to the other, gives the magnitude of the angle. Magnitude of an angle, what is this? It is the amount of rotation through which one of the arms must be rotated about the vertex to bring it to the position of the other. Okay, comparing two angles, we can compare the magnitude of two angles by the following methods. Okay, so number one method is by observation. Here we can compare two angles by mere observation and inspection. Clearly this angle, that is angle 1, is greater than angle 2. Okay. Number 2 is by using tracing paper. Suppose that we have to compare two angles, angle ABC and angle DEF. Okay. So by looking at a glance, we see that both are looking equal. Okay, but maybe there is a slight difference. Okay, so that's why we will use a tracing paper. Okay, what will you do? We place a tracing paper on one of the angles, say DEF. Okay, we can take any angle, either DEF or angle ABC, right? We copy it on tracing paper. Now place the traced angle DEF or angle ABC such that E coincides with B and ray EF lies along BC. Now we get three possibilities as shown in the figures. Okay, see, possibility 1, 2 and 3. Okay, so possibility 1, ED lies between rays B and ABC and BC, then angle DEF is less than angle ABC. 2, second, ED lies beyond BA, then angle DEF is greater than angle ABC. And third, ED lies along ray BA, then angle DEF is equals to angle ABC. Okay. Degree measure of an angle. The standard unit of measuring an angle is degree. We use the symbol this to denote degrees. Consider a ray OA, keeping O fixed, rotate OA starting from its initial position as shown below. Okay. And then when the ray OA completes one full rotation, we say that the ray has made one full turn. We divide this full turn into 360 equal parts called degrees. 1 degree is written as like this, 1 degree. Thus, one turn or complete rotation of OA is equals to 360 degree. If the ray OA takes a quarter turn, then we say that the ray moved to an angle of 360 by 4 is equals to 90 degree. An angle of measure 90 degrees is called a right angle, which you already know, right? This is a complete angle, this is a right angle, this is straight angle, and this is 0 angle. Okay. So if the ray OA takes half a turn, we say that OA has moved through an angle of 360 degree divided by 2, that is 180. An angle measure of 180 is called a straight line, a straight angle. An angle measure of 360 degrees is called a complete angle. However, if the ray OA doesn't move at all, we say that ray has moved through an angle of 0 degree. That means an angle of measure 0 degree is called a 0 angle. Okay. Now, types of angles. The different kinds of angles are shown below. Number 1, right angle. An angle whose measure is 90 degrees is called a right angle. Number 2, acute angle. An angle whose measure is greater than 0 degree but less than 90 degrees is called an acute angle. 3, obtuse angle. An angle whose measure is more than 90 degree but less than 180 degrees is called an obtuse angle. 4, straight angle. An angle whose measure is equal to 180 degrees is called a straight angle. 5, reflex angle. An angle whose measure is more than 180 degree but less than 360 degree is called a reflex angle. 6, complete angle. An angle whose measure is 360 degrees is called a complete angle. Number 7, 0 angle. If the initial and final position of ray OA are same, we say that it has made a 0 angle. Okay. As you can see here, this is right angle. See, acute angle because it is less than 90 degree. Obtuse angle, it is greater than 90 degree. You know, 90, this is 90 degree or right angle. Straight angle, this is reflex angle, means greater than 180 but less than 360. This is complete angle, okay, and this is 0 angle, okay. Now, measuring an angle by a protractor. Protractor is an instrument for measuring and constructing an angle of given measures. It is a semicircular metal or plastic which is marked in degrees from 0 degree to 180 degree, from left to right as well as from right to left as shown in the figure. As you can see, this is the protractor which is in the shape of semicircle, that is half of circle, and normally we also call it D because it forms the shape of alphabet D. Okay. The center of this P is also called the midpoint of its baseline, right? Example 1, find the measure of the angles given below by using a protractor. Okay, so here are the angles given to you. You have to measure the angles by using the protractor. Now, what is the procedure? Number 1, to measure angle AOB, this one, place the protractor in such a way that its center is exactly on the vertex of the straight angle and the baseline lies along the arm OA. Now, read the mark on the protractor through which OB passes, starting from 0 degree on the side of A as shown in the figure. Okay. Now, measure of angle AOB is what? 40 degree. Number 2, to measure angle PQR, place the protractor in such a way that its center is exactly on the vertex Q and the baseline lies along the arm PQ. We read the mark on the protractor through which arm QR passes, starting from 0 degree on the side of P. So, we read the measure of angle PQR is equals to 134 degree. Note. Number 1, compare the given measure of angles with the right angle to get correct position. 2, in the protractor, use the clockwise reading for clockwise rotation. Number 3, use the anti-clockwise reading for anti-clockwise rotation, right? Exercise 16.2. Classify the following as acute, obtuse, right, straight or a reflex angle. As you can see, this angle is greater than 90, so this is obtuse angle. Okay. Number 2, this is right angle. And this is what? Straight angle, right? and this is reflex angle because it is greater than 180 but less than 360, right? Pairs of angles. Often we come across pairs of angles that have some properties and relationships. Some of them are described below. Number 1, adjacent angles. Consider the figure. Angles BOC and angle AOB are adjacent angles. So, two angles in a plane are said to be adjacent if they have a common vertex, a common arm, and number 3, other arms are on opposite sides of the common arm. In the upper figure, arm OA and OC are on either side of the common arm OB. The arms have a common vertex O. Okay. Number 2, complementary angles. If the sum of measures of two angles is 90 degree, they are said to be the complementary angles. Each of them is called the complement of the other. Examples. Number 1, angles 25 degree and 65 degree are complementary angles. Number 2, the complement of angles 60 degrees 30 degree and the complement of angle 30 degrees 60 degree. Because if you add these two angles, you will get a 90 degree. Okay. Number 3, supplementary angles. Consider the figure. Here the sum of two adjacent angles, angle AOB and angle BOC is 180. Such pair of angles are supplementary angles. 60 plus 120 is 180, right? Thus, if the sum of two angles is 180 degree, then they are said to be supplementary angles. Each of them is called the supplement of the other. Number 4, linear pair. Consider the following figure. Here the adjacent angles form a linear pair. It is called linear because the non-common arms form a straight line. Thus, the two adjacent angles form a linear pair if their non-common arms form a straight line. Okay. A pair of adjacent angles need to form a linear pair, but the angles forming a linear pair are adjacent angles. Okay. Next, vertically opposite angles. Let two lines L and M intersect at O, forming angles 1, 2, 3 and 4. Okay. This is line L, this is line M. Okay. These are intersecting at this point and making 4 angles. 1, 2, 3 and a 4. Okay. Here angles 1 and 3. 1 and 3 are what? Vertically opposite to each other, and 2 and 4 are vertically opposite angles. These angles have no common arm. Thus, two angles formed by two intersecting lines having no common arm are said to be vertically opposite angles. Further, it can be proved that vertically opposite angles are always equal to each other. Okay. Exercise 16.3. In the figure, number 1, are angle 1 and angle 2 adjacent angles? Okay. See, angle 1 and angle 2, do they have a common vertex? Yes, they do have a common vertex, which is O. Do they have a common arm? Yes, OB. So, yes, angle 1 and angle 2 are adjacent angles. Second is angle DOE. See, this is DOE, adjacent to angle COE? No. Okay. Learning outcomes. Number 1, an angle is a figure formed by two rays with the same initial point called the vertex, and the two rays are called arms of the angle. Number 2, one complete angle is equals to 360 degree, one straight angle is equals to 180 degree, one right angle is 90 degree. Angles less than 90 degree are acute angles, angles greater than 90 degree and less than 180 degree are obtuse angles, and angles more than 180 degree and less than 360 degree are reflex angles. 3, two angles with a common arm and the other arm lying on the opposite sides of the common arm form a pair of adjacent angles. 4, adjacent arms whose two non-common arms are opposite rays form a linear pair. 5, the angles formed by two intersecting lines having no common arm are said to be vertically opposite angles and are always equal. 6, two angles whose sum is 90 degree are called complementary angles. Also, each angle is called the complement of the other. 7, the two angles whose sum is 180 degree are called supplementary angle. Also, each angle is called the supplement of the other. And 8, two angles forming a linear pair are adjacent and supplementary. And number 9, two supplementary angles form a linear pair. Right, students? Now, you will do practice of the remaining questions.